let's do some practice problems. Here's a nice integral. How about integration by parts maybe? So go ahead and choose your u and dv. If you haven't chosen them yet, maybe pause and then come back. Here's what I would think. Think about liate. And do I have any logs? No. Do I have any inverse trig? No. Do I have any algebraic stuff like polynomial? Yes, I do. The t here is a very simple polynomial, right? So I'm going to say u equals t, and then what's left over, the cosine 3t dt would be dv. And then what's the next thing to do? Take the derivative of the u and the antiderivative of dv. So we'll get du equals dt, and dv becomes v. What's the antiderivative of cosine 3t? Well, antiderivative of cosine is sine of the same thing. And if we were doing u substitution, which we kind of are doing behind the scenes, we would get a factor of 1/3. Remember, that's one of those formulas I said would be really handy. You quite often have a frequency term here, and you end up getting a 1 over that when you take the antiderivative. All right, let's write the u substitution formula. So integral of u dv, which we already have, equals uv minus integral v du. And then let's write each thing right underneath the associated part, just to help try to keep things nice and neat. So u is t, v is 1/3 sine 3t, minus the integral of, what's v, 1/3 sine 3t, and du is just dt. Are we done? No, we still have an integral. So then we can just copy this part. The 1/3 is a constant multiplying factor, so that's going to stay there. What's the integral of sine 3t? Integral of sine is negative cosine 3t, and then times a 1/3, which we would, if we were doing u substitution, we'd get that extra factor of 1/3. So notice I have two factors of 1/3 now, one that came from doing dv to v, and then one from taking the antiderivative here. And then that's the end of the integral, so we can just say plus c. Is this right, or did I make a mistake just to make a mistake and see if you catch me? I made a mistake. I need a multiply sign here. Otherwise, I'm going to be having just a 1/3 subtracted and then subtracting a cosine from that. So what's my next tactic here? Check it by taking the derivative by hand. So take this whole thing, derivative. What's the derivative of this part? I'm going to need the product rule, which makes sense because integration by parts is the opposite of the product rule. So I'm going to get t prime times 1/3 sine 3t minus, plus for the product rule, t times 1/3 sine 3t prime. I'm kind of letting my columns run all crazy here. So that's the product rule. Here, let's highlight that this part all comes from that part right there. And then the derivative of this, I'll have a negative 1/3 times negative. What's the derivative of cosine? It's negative sine 3t times 1/3 times 3t prime for the chain rule. And then let's simplify this. T prime is just 1/3 sine 3t plus t, so that t there, times 1/3, what's the derivative of sine 3t? It's cosine 3t times 3t prime. minus 1/3. I'm going to collapse those minus signs and just not write anything at all. And then sine 3t times 1/3 times 3. And what can we make from this? This is going to be the same, 1/3 sine 3t. Right now it's not looking good. I didn't have a 1/3 sine 3t in my original integral, did I? What's going to happen here? T times 1/3 cosine 3t times 3, and then minus, what's going to happen here? The 1/3 cancels the 3, I get 1/3 sine 3t. Phew, now what? This part here and that part there are the same but with a minus, so I can cancel those. And the 3 here cancels the 1/3. And so I get t times cosine 3t, which is indeed what we started with. So that checks out. Phew. All right, let's do another one. Let's do the integral of t squared e to the t dt. Now, this actually isn't all that useful of a function. What's more useful is t squared e to the negative t, because that's a surge curve. But we're just taking a kind of stepping stone approach here. So let's write over here, t squared e to the negative t is more interesting. But let's take small steps. So what would you say to do for u and dv here? Take a sec to think about it. Well, I don't have any logs, I don't have any inverse trig. I do have an algebraic thing, the t squared. So u equals t squared. And then what is dv? It is everything left over after the t squared, so e to the t dt. So go ahead and do the next step. Du equals 2t dt. And what's the antiderivative of e to the t? It's just e to the t. All right, so go ahead and write the integration by parts formula and plug stuff in and see what you get. So we've got u times v minus the integral v times du. It's often nice to give it a little extra space so you don't run out of space for your columns like I did up there. Don't do like I did, right? Up there. So u is t squared, v is e to the t, minus the integral of v, which is e to the t, times 2t dt. All right, so does that look good? Well, how am I going to integrate this? E to the t times t with the 2 there. So let's move the 2 out and write it like this, t e to the t dt. That's just the problem we did when we were first introducing integration by parts. We need to do integration by parts on this, except we already did integration by parts on this exact formula, so we could just go back and copy that. That is math, reusing what you've already learned, right? So we could say this needs integration by parts again, but we already did it. So just copy the result. So overall we've got t squared e to the t minus 2, and then if we look back at the previous video, we get t e to the t minus e to the t plus c. And what's left to do? Take the antiderivative by hand to check it. I'll let you do that part. what do you think will happen when you're taking the antiderivative by hand? Probably have product rule on this part, which will give you two terms, and then product rule on this part, which will give you two terms, one of which cancels the other, and then one of these terms from over here is going to cancel one of these terms from over here, and we should be good. That should happen every single time when you're doing integration by parts, right? The whole thing is designed to give you two terms from one derivative when you're taking derivatives to check, and then everything else gives you something that cancels one of those terms that you didn't want. All right, let's try something else in the next video.